Let's start new lesson, that is force, motion and work. Motion, force and work. Lesson number 7. This lesson is a physics lesson. This is an introductory lesson. Throughout life, okay, these concepts are useful to you. Let's observe and discuss. Figure 7.4. Work. In first picture, horse and horse rider both are in motion. Grazing cow is in motion. Cart is motion. That cart man is motion. Pressure cookers whistle is motion. And boiling milk is also in motion. These all are examples of motion. Let's study what is meant by motion. What causes change in motion? Simple answer is there. Motion means movement. Movement is called motion. Last year we have studied change occurs in motion of body when force acts on it. Change occurs in the shape of body when force acts on it. Let's study how work is done. Okay, before that we will study subtopic, that is distance and displacement. Observe figure 7.2. In this figure, on point A, Ranjit house is there, and at point B, his school is there. Ranjit traversed for school and he followed path A to B, B to C and C to D. So he has not followed a straight path. Continuously he was changing direction. So A to B direction. Okay, so A to B, B to C and C to D. So A to B distance he have traversed, that is 500 meters, and he has taken time 8 minutes. B to C distance he have traversed and total distance was 700 meter and he has taken time 11 minutes. When C to D distance he traversed, it was 300 meter and he has taken time 6 minutes. So if we will add these all distance A, B, B, C and C, D. So total distance he has traversed 1500 meters and total time he has taken, that is 25 minutes. So he changed the speed and direction also. This example is of distance. Here Ranjit do not follow a straight direction. When direction is not considered, it is called distance. The length of the route actually traversed by a moving body irrespective to direction, means here direction is not considered, not mentioned. So okay, it is called distance is called distance. Distance is a scalar quantity as direction is not mentioned or specific direction is not there. In distance, direction is not taken into account. So let's study what is displacement. Ranjit's displacement from his house to school is shown in a straight broken line. He has traversed directly A to D. It's a displacement. The minimum distance traversed in a particular direction along a straight line is called a displacement. As direction is considered in second example, okay, it is a vector. Displacement is a vector quantity. A displacement, the minimum distance traversed by a moving body in one direction from original point to the final point is called displacement. In displacement, both distance and direction are taken into account. So he has started journey from A and directly A and reached up to the D. Total distance he has traversed 1000 meter and time he has taken 25 seconds. Both distance and displacement are measured in meter in SI means international system as well as in MKS system. So distance is measured in meters in SI means and in MKS system. So let's study second subtopic, speed and velocity. When we are saying speed of a car 40 km per hour, there is no need to specify the direction. But when you are predicting whether a storm will reach, mentioning a particular place or a direction is necessary. Let's find the unit of speed. Unit of speed. Okay, speed's formula is distance upon time. Hence, distance is measured in meter, time is measured in second. So, unit of speed is meter per second. Velocity's formula is displacement upon time. So in displacement is measured in meter, time is measured in second, hence velocity's unit is meter per second. So let's use this formula to find out velocity and speed. When Ranjit goes to school, distance travelled by Ranjit is AB plus BC plus CD, means total distance he has travelled 1500 kilometers. When we add 500 plus 700 plus 300, total distance he travelled is 1500 meter, and time he has taken 25 minutes. So let's keep this value in a speeds formula. So 500 meters upon 25 minutes is equal to 1 meter per second. If you will divide 1500 meters upon 25, answer will come 1 meter per second. Okay, 1 meter per second. So next, displacement. So 1000 meter distance he has travelled in 25 minutes. For velocity's formula is displacement upon time. So total displacement is 1000 meter and time taken is 25 minutes. So if we will calculate this 1000 upon 25, you will get 0.66 meters in 66 meters per second. So Ranjit did not take the straight route of minimum distance while going to the school. So Ranjit has not followed a straight path, therefore the magnitudes of his velocity and speed come out to be different. Okay, had Ranjit actually gone by the straight route AD, then the magnitude of his velocity and speed would have been same. So he has not followed same path. Okay, in first example he has gone zigzag, and in second example he has gone straight, hence velocity and speed's magnitude come different. Okay, so speed's magnitude 1 meter per second and velocity's magnitude 0.66 meter per second. So different magnitudes has come as Ranjit has not followed the straight path. If he has followed the straight path, there will be same velocity and speed. Let's start next subtopic, average velocity and instantaneous velocity. Average velocity means total velocity upon total distance upon total time, and instantaneous velocity means particular point velocity at particular point is called instantaneous velocity. So see students 7.3 figure. Here truck is traversed, total distance truck is traversed is 40 km and time taken is 60 minutes. So if we will keep these values in velocity's formula is total distance upon total displacement upon total time. So 40 km upon 60 minutes. Okay, so 40 km upon 60 minutes means average velocity is 40 km per hour. Here average velocity is 40 km per hour. So students, we will see instantaneous velocity for the distance AB. Here we are not considering the distance AD. For average velocity we have considered the distance A to direct D, and it was 40 km and time was 60 minutes. But in instantaneous velocity we are considering just AB, and AB's distance is 10 km and time taken is 10 minutes. So if we will keep these values in a formula of velocity, 10 km upon 10 minutes. So multiply these both the values with 60. So if we multiply 1 km into 60, answer is 60 km, and 10 minutes in 1 minute into 10 minutes into 60, so it is 60 minutes. So answer will be 60 km per hour. So this 60 km per hour is the instantaneous velocity. We will see velocity of BC. So in velocity of BC, total distance is 10 kilometer and time is 20 minutes. So if we will multiply both the value with so here instantaneous velocity will come 0.5 kilometer per minute. So you can calculate velocity of CD. Okay, total distance is 20 kilometer and time taken is 30 minutes. So if we are considering just a particular point's velocity, then it is called instantaneous velocity. The velocity at a particular moment of time is called instantaneous velocity. The instantaneous velocity can be different at different times. Students, here I'm explaining instantaneous velocity again. Here just you have to consider A to B distance. A to B distance is 10 kilometer and time is 10 minutes. So 10 kilometer upon 10 minutes. So you have to multiply it with 6. So answer will come 60. 10 kilometer into 6 is equal to 60 kilometer. 10 minutes into 6 is equal to 6 minutes. So if you will divide these two values, answer will come 60 kilometer per hour. Okay, so this is the instantaneous velocity of AB. Dear students, in next video we will study acceleration, force and acceleration, Newton's first law, force, displacement and work. So students, whatever I have taught in these videos, listen it carefully, read lesson and study regularly. Thank you very much.